Good day, my name is Nkosi. I work as a researcher at the CSIR in South Africa. I'm also a student with the University of Stellenbosch. My presentation today is going to be titled Techno-economic analysis of 5G network slicing, focusing on enhanced mobile broadband slice services. Okay. Now, with 5G officially launched worldwide, network providers and operators are seeking ideal cost-efficient methods of offering 5G services. Therefore, it is important to perform calculations to identify cost-efficient combinations of technologies and functionalities in order to identify business solutions relevant to different markets. So now, as a start to developing sustainable business models for rural markets, this work provides a cost analysis of offering 5G eMBB services by considering two scenarios. The first one being own slice implementation, and the second one being a lease slice in a scenario. Now, CapEx and OpEx of the two methods will be compared to identify the most cost-efficient option of offering these services from a small business point of view. So now one of the issues that we identify is that most operators struggle to develop sustainable business model for new technologies. That's one of the reasons why the biggest motivation of this study. So now, the research objective of the study is that a costing model for a 5G slice network offering eMBB services is investigated in order to estimate CapEx, OpEx, and total cost of ownership. And the proposed cost analysis may also serve as an input to determine the efficient pricing models of slicing-enabled services. So this work aims to identify options of providing slicing-enabled services in terms of cost from infrastructure point of view. One key question that this work aims to answer is, what is the ideal option of providing network services for eMBB video services in emerging markets? Okay. The network that's going to be used to do the analysis is built based on key technologies such as software-defined networking, network function virtualization, cloud computing, and orchestration. Now, software-defined networking allows for flexible capacity planning and routing based on real-time needs. NFV enables the separation of software from hardware to make it possible to implement network functions on common infrastructure. Cloud computing enables the use of software to create virtual network resources, whereas orchestration, allows for easier end-to-end slice management. Now, to ensure a cost-efficient architecture, all the configurations of the virtual machines in our networks were fixed and categorized into three types as highlighted here: type 1, type 2, type 3, meaning that each VM will be of type 1, of type 2, or type 3. This is to ensure that it's easier to come and calculate number of resources that are required for configuring data center resources. So in summary, the proposed model is built on, number one, each network slice supports one specific service, which in our case is eMBB video service. And each slice is an end-to-end connection of the RAN and the backhaul, which is a transport network, and the core network. So On the core network, a slice consists of virtual network functions, which are changed together programmatically, and the VNFs run on virtual machines, which are implemented on servers with each one of those VMs following the predefined types that I've already mentioned. And the throughput is predefined and configured on the backhaul statically. Okay. Now, in order to determine the infrastructure required, VNF dimensioning and VM mappings were done. So the VNF dimensioning was to determine the number of VMs required for each VNF. VM mappings was to determine the total number of infrastructure required. Now, each slice, to determine each slice cost, each slice cost were determined by calculating the cost of throughput for that slice and the total number of VMs and the total number of physical network functions that were used by that slice. So all those summed together will give us the cost of each slice. So now the cost analysis method. In trying to come up with the cost analysis, I've already explained. The first was to determine a number of infrastructure that was determined. So in that first thing that was determined was the cost of each slice. And now in the cost analysis, now for our first scenario, as I mentioned when I started, for the own slice, when the network provider owns the infrastructure. So the first scenario focused on that. So the capex was calculated as the cost of RAN and the cost of the backhaul, plus the cost of the 5G core, plus the cost of the servers. The servers are the total number of servers that are required based on the calculations of number of slices that a network provider has in their network, plus the cost of the cooling system that is used in the data center, plus the cost of installation, that is setting up all these servers and the softwares in order to come create slices, and then the cost of site where the data center is being set up. And then the cost for OPEX, it was a summation of cost of maintenance, which is the total cost of network maintenance per year, which is calculated as a 10% of the capex, and then also the total cost of power consumptions for the cooling system per year, and the P, which is the total cost of power consumption per server per year, which are all multiplied by the cost of each kilowatt, multiplied by the number of servers. So the total cost of ownership, TCO, was calculated as the summation of the capex and the OPEX, plus an overhead, which was calculated as the 22% of the total capex. Okay. Now on the least slice scenario, the capex was calculated as the cost of license once-off, which is a once-off cost of the virtual network functions, plus OPEX, which is calculated as the rent, which is a monthly cost that the network provider has on the network, plus the cost of the software upgrades per month. Now, having all of this, the analysis that we came down to is that it's interpreted on the slides. Now, from this diagram, several interpretations can be extracted. Firstly, as it is expected, the own slice, which is represented by blue, the own slice bears significant amount of capex, about 50% more. This is because money is spent on infrastructure acquisition and installation. On the other hand, the least slice, which is represented by the orange color. The least slice exhibits more OPEX, about 70, as it is, can be seen here, 70% more as compared to the own. This is because least slice spends more on rental cost per month as compared to the own slice. Now, from this cost analysis, it can be deducted that it can be concluded that the least slice scenario is the one that is the best option for medium and small business owners in providing the eMBB services. So the own slice would be ideal if the network provider is to provide more services to provide more services other than just one service, because the network infrastructure is there and it's costly. So it will return more, it will be more beneficial if the network operator can offer more services other than just one. Now, as a technology, and network slicing has proven to enable new business opportunities and innovation for network service providers. However, for both scenarios, effective and sustainable business models for different markets are still required. Okay, in conclusion, this paper provided the cost analysis for 5G slice network by comparing two scenarios from a small, medium, micro enterprise service provider point of view. Their aim as a start was to determine an ideal cost-efficient scenario for this service providers. This cost model can also be used as an input towards the development of sustainable business model for eMBBs, and also for different markets. I thank you so much for your attention, and I will now take questions.